Hello everyone, this video is going to be on programming the AR3 robot. I've made a series of videos previously for the AR2 for programming. Those videos are still applicable, but they were kind of an evolution as the program developed and as more things were added, the video series progressed. So I wanted to make a new video that kind of starts at the beginning and includes all of the current buttons and functions of the program. So assuming you've started up your robot and you've already gone through the startup video, you've already set up your COM ports, you're connected and running, I wanted to start out with jogging. So up here in the upper right portion of the panel, we have all of our jogging buttons for the joint mode. So each of these buttons will jog each individual joint by the amount shown in the degrees to jog field. So for example, if we wanted to jog joint 1 in the negative direction or in the positive direction, that's what these buttons here will do. They will jog each individual joint. This section of buttons here is for Cartesian, for jogging the robot in the X, Y, Z, yaw, pitch, or roll directions. So just for example here, if I wanted to jog the robot forward in the X direction, I can press the forward or the back, and then in the Y direction, side to side, that will jog the robot in the Y direction. And then the Z direction, of course, is up and down. So that's what this group of buttons here is jogging in Cartesian. This group of buttons here, you see it says TX, TY, TZ, and so on. This is for tool. So what this means when we say we're jogging according to tool, we're jogging according to the gripper. So for example, the face of the gripper right here, this is the X side of the gripper. So if I jog in the X direction, it's going to jog in and out according to the gripper. So just to show you a quick example of that, with the X direction, if I hit minus, it's going to go in the direction of the face of the gripper, or back down in the face of the gripper. So that's what all these buttons here are, is for jogging according to the tool. The next thing is that I want to talk about is the speed. Everything is in percentage of maximum. So right now I have the robot set to go at 10% speed, and then the acceleration and deceleration are also in percents of speed. So when I set all of these values, they're applicable for jogging, and if I teach a position, it will use these values for the top speed as well. So whatever you have this set to, if you teach a position, that's the speed that the position will run to. Now the acceleration and deceleration has two values. The first one you can see is duration, and the second one is speed. So I have it here set for 15% duration, which means 15% of the move. So for example, if I had a move that was 100 millimeters long, the acceleration would be applicable to the first 15% of that move. So if it was 100 millimeters long, it'd be the first 15 millimeters that the acceleration would be applied to. And then the percentage is percentage of the total speed that you have it set to. So this would be 10% of whatever you have in this field. So in this example, it would be 1%. So in this excuse me, in this scenario, the duration of 15 means that it would accelerate from 1% up to 10% over the first 15 millimeters of the move. And then the deceleration is the same thing. In this example, it has 20%. So the last 20 millimeters of the move, it would decrease from the 10% down to 0.5% of the total move. So the next topic is the Xbox controller. So I've got my wireless Xbox controller, and I've purchased a USB receiver, like you see here, and have that plugged into my computer. I didn't have to install any software. Windows automatically picked it up. And to test that, you could go into the search bar below and type in joy.cpl, and what that'll do is it'll open up your game controllers window, and you can see here we've got the Xbox controller. Once I've pressed the connect button right here on my controller and the connect button right here on my receiver, you will see the game controller pop up right here, and I can click on properties, and just verify that the buttons are working. So for example, if I press the buttons here, you can see them light up on the screen there in the controller properties box there. So we will close that and that. And so now if I want to control the robot with a controller, I can click on the Xbox on button, and you can see this illuminates green. All of my movement distances have all defaulted to 5, and you can see up here that it says jogging joints 1 and 2. So now the Xbox controller is in control of all of the robot movements. So a couple of things here. The trigger buttons will control the distance to move. So if you're jogging the robot and you want to change the distance, you can, for example, press the right trigger, and then you can see here all of my distances have changed to 10, 15. They'll climb in increments of 5, and once I get down to 5, then it will decrease in increments of 1. So that gives me the ability, while I'm holding the controller, to change the distance. And then the bumper buttons up here, up on the top, those will change the speed. So you can see the speed goes up by 5 or down by 5. Now, so those are the distances and speed. So the next thing is the jogging methods. So the X button controls jogging and joints. So when I press that, you can see that my window right up here where it says jogging and joints, every time I press the X, it will toggle which joints I'm controlling. So right now I'm controlling joints 1 and 2. I press it again, I'll be controlling joints 3 and 4. Press it again, I'm controlling joints 5 and 6, and then back to joints 1 and 2. So now when I press left or right on the controller, the robot will be, that's joint 1, and then up and down is joint 2. And then if I press the X button, then the same thing, then I'd be controlling joints 3 and 4, and then joints 5 and 6. Now the A button down here is going to switch us from joint mode to Cartesian mode. So I click that, and now you can see up here, now I'm jogging in the X and Y axis, and if I press it again, I'll be jogging in the Z axis. I press it again, I go back to the X and Y axis. So let's change the distance up here to, let's see, 40, and then let's try that out. So jogging in the X direction, or excuse me, that's the Y direction, side to side there, and then the X direction up and down. And then if I press the A button again, that'll switch us to Z. So now down should take the robot down and up. And then the B button changes us to reorient. So if I wanted to reorient a joint, that'll change to the reorient mode. So I can reorient the wrist of the robot in reorient. And then if I wanted to jog the track, if we had a track set up, and I'll do a future video on a track, I can press the back button right here, and I press the back button, it goes to track, and then I would of course be able to jog the robot on its track. I don't have one set up right now. And then the start button will control the first. If I go here to my input outputs, and right here to my first input outputs, I'm using digital output 45 to control my gripper. So the start button will control whatever you have wired into whatever outputs is designated here on your first group of input outputs would be my gripper. I don't have my air compressor in here and powered up at the moment, but if I press that, it would open and close the gripper. And then the last thing is teaching a position. So let's move that over here. And so right now I'm set to a joint move, and we'll go over the different moves in a minute. But if I set that to joint move, and I put the cursor right there, and I was to press the top button, the Y button, it will teach a new position. So whatever you have selected here, whether it's a joint move, a linear move, or what have you, whatever selected is what it will put in the program when you press the Y button. So that's all the functions on the Xbox controller. The next thing I wanted to talk about was loading a program. Here in this window right here is where you can build your program. And if you want to load a program right here in this field, you can enter in the program name. So for example, right now we have the home program loaded. This home program just simply contains one move that brings the robot to a home position, which is kind of a 90-degree position, similar to what's shown here on the screen. We also have the rest program where I can type in rest and hit load program, and it will load in a different move here. And this move, if executed, will run the robot to a vertical position for the rest position where it can be powered off. And then if I wanted to create a new program that doesn't exist, I could just type that into this field here. So for example, if I just wanted to call the program new program and press the load program button, it will look for that program, and if it doesn't exist, it will create it. So I hit load program, and now it has just created a new program that is called new program, and it starts out with a blank window here that says beginning of program and tab number 1, and we'll talk about tabs in a little bit. But for example, if I wanted to put something in here, I could come down here to the manual entry field and type in some text here. So I could type in, comment or whatever, and hit insert. And every time I hit insert, it'll insert that into the program. And so now, just for an example to show you, if I went back to the rest program and hit load program, it will go back to the rest position. And then if I type in new program, it will look for that, and it will pull up the program that we created previously. Now, if you want to see where these programs live, if you open up the folder for where your software resides, you will see in that folder, for example, here's my home program, here's my rest program, and then here's the new program I just created. So if, for example, I wanted to archive a program or delete a program, I could just come in here and just delete that out of there. And then when I come back here, and let's change out of it to our rest program, hit load program, and now when I go back to new program, it doesn't exist anymore. So it will create it, and all the comments that we typed in there will be gone. So I hit load program, and it again creates a brand new program since we deleted it. So next I want to go over the first couple columns of buttons here to add functions to the program. So starting out here with the moves, I'm going to come back to these and go into more detail on each of the move types, but we're going to start out with just a move J, which is just your regular joint move. And if you press the teach new position button, it's going to teach a new position, and it's going to be the type of move that you have selected from this list. So since we've got move J selected and we hit teach new position, it's going to add a line of code right here. So when I select that, it's going to teach a new position, which is exactly where it was at from our program that we're in called new program. So the next button is modify position. So if I were to jog the robot to a new position, so let's move the robot a little bit, and then I'm highlighted over this line and I hit modify position, it's going to modify that to be the new position that we've jogged the robot to. And then we've got the delete button where I can just delete a line of code from the program. And then we've got the call program button to call a program. So for example, if I wanted to call the rest program right here, I could put that in, and then we get a line of code that says call program rest. So if I execute that, you can see we go right into the rest program. So now we're at the top of the rest program, and I execute that, and the robot will go to the rest position. So that brings us to the next button, the return button. So if you call a program, you can only go one program deep, and if you want to return to the program you came from, the program has to have a return at the bottom of it. So I will click that and put a return on there, and it looks like I was one line too low, so I'll delete that and then put in a return right below it. So now if I execute the return, it's going to go back to new program where we left off, and the program pointer will be right here, and you can see it's highlighted dark blue, so it's at the end of its program. So that's how we return from a program. The next thing is wait time, so you can put in a wait time. So we'll put in 1 second and put our cursor right there and insert a wait time. So that will add a wait time to our program. The next button is wait input on and wait input off. So if you wanted the robot to wait for something to happen, wait for an input to come on, you would use this function here. So for example, if I was using input 2, for example, I could put that in my code, and the program pointer will basically just sit here and wait for that input to come on. Something to keep in mind with Arduino inputs, they float, meaning that unless you provide the input a negative signal or a positive signal, it can float. So you'll just randomly get a high signal or randomly get a low signal, and it won't behave the way you expect. So what you have to do is on that input, you have to use a normally open, normally closed switch for your input, so that when you wire it in under normal conditions, well, your switch is not made, it's providing 0 volts to the input, and then when your switch becomes made, it switches to positive 5 volts, and then at that point this condition will be satisfied and it will move past it. So it's exactly the same way that all the limit switches are wired. The limit switches on the robot are wired so that they're providing 0 volts when the switch is not made, and they provide 5 volts when the switch is made. So these inputs need to be wired the same way. And then we have if we were to use input 3, for example, and we wanted to wait for that input to come off, it's the same thing. You would either need a switch that was wired so it was providing 5 volts, positive 5 volts when the signal is not made, and then when the switch is made, provide a ground or negative signal to the pin so that it would move past this point in the program. Or you could go into the Arduino code and change your input to an input pull-up type to add a pull-up resistor to it. But just be aware with the waiting for inputs on and waiting for the inputs off, that can be a little bit tricky, as the floating voltage can really mess with you. So the next button is set output on and set output off. These ones will turn Arduino outputs on the Arduino Mega on or off. So these are what I'm using in the program to control my gripper. My gripper is wired to output 45. Output 45, it goes to the relay that controls my solenoid that controls the air on and off for my gripper. So in all my programs, if I wanted my gripper to open or close, I would use these, and I'm using output 45 on my gripper, so I would put 45 in there, and then I could set output on or set output off, and that would either open or close my gripper. So next I want to talk about the final 2 columns of buttons, and we're actually going to start on the second column over here with create tab and jump to tab. So these are ways to navigate through the program and jump around in the program. It's very much like BASIC, it's very simple. So I'm going to start out with I'm going to jog the robot to a new position, and then I'm going to teach a new position, and then I'm going to add this function called jump to tab, and I'm going to put in jump to tab 1, and you can see up here we already have tab number 1. So if I'm down here in my bottom row and I add that line, when I execute that line, it's going to jump up here and put us into a loop. So if I hit play at this point, the robot is just going to endlessly go back and forth and go through that loop. But it doesn't have a way out. It's just going to keep running through this loop endlessly. So I'm going to hit stop. And so now the program is stopped. So if I wanted a way out of this program, then I would either use if a register equals a certain value to jump to a different tab, or I would use if on jump, or if an input is on, then jump to a different tab. So what I'm going to do right here is I'm going to come right below this jump to tab 1, and I'm going to create a new tab, and we're going to create tab number 2, and I'm going to put that right there. And then what I would then do is right here within the inside of this loop, could really be anywhere within this loop, but I typically put it at the end of the last move there. I would put for example, if input 1 was on, then I would jump to tab 2, and I could put that right here. So what that's going to do is it's going to start running through this, and when it evaluates this line of code, if the input comes on, then it's going to jump down here to tab 2 to the end. But if that input is not on, then it's going to move to the next line and go back into its loop. So you could use this in a scenario where you wanted it to keep looping endlessly until you push a button or until an input comes on, and then you could make it jump here to the end, and the program would then stop at that point. So this now brings us to the topic of registers that I'd like to get into. So we're going to skip over the servo button for now. We'll come back to that and go to registers. So if we go here to the register tab, there's 2 types of registers. There's just regular counting registers. There's 16 of them that you can use, and this is just strictly a single number for counting purposes. And then in this column, these are stored position registers. So this is where we can store a position, and we'll come back to this in a few minutes. But what I want to focus on is counting registers. So if we come back to the main program, we have a button here called register where we can set a register equal to a value. So I'm going to come in here in my program, and I'm going to take this if on jump statement. I'm going to delete that, and then for an example, I'm going to take register number 1, and we're going to set it equal to, just to show you an example, let's say we want to set it to be 3. So I can put that in my program, and if we come back here and look at our registers, right now register 1 is a 0. If we come back here to our main controls and we highlight that line and execute it, and we come back to our register tab, that register is now a 3. So we can set registers equal to any value we want in the program. Now if we want to use them for counting, we can increment or decrement. So what I could do is I'm going to delete that line, and then over here, if I don't want to just set it to a static value, I want it to increment by some amount, I would put in a double plus, so 2 pluses. And then I could put in the value by which I want it to increment. So if I put in a 1 there, it's gonna increment by 1. So let's put that in the program and see what happens. So when I execute that and we go back to our register tab, now it's a 4. It's incremented by 1. If I execute it again, now we're a 5. So it's going to continue to count. Now if I want to I'm going to delete that out of there. So now let's say I wanted to count by 5s. You could put any number you want in here. I could do a 5. And so we could put that in our program and execute it. And we come back to the registers tab, and now it's at a 10. So that will allow us to increment or decrement. If I delete that and I was to put in a double minus and put that in the program and execute it, we come back to our register tab, you can see now it's a 5. It's decremented by 5. So that gives us the ability to count in our program. So what I'm going to do is I'm going to change this. Let's delete that, and let's change it to, let's go back to ++1, and we will put that in our program. So now every time that it runs through this loop, it's going to increment by 1. What I want to do at the very beginning of my program, before I get to this tab, the point I'm going to jump in at, let's put our cursor right there, and or excuse me, right there, and then let's put in register 1 is equal to 0, and we'll put that in our program. So now before it gets to tab 1, the first thing, if we were to start right here, it's going to set register 1 to 0. It's going to make these 2 moves. It's going to count up, and then it's going to jump back to the top. So it's just going to keep going like that, and it's just going to keep counting. But let's say I want some way out of the program after, let's say I want after it's done 5 times, I could come right here at the top of my loop, and I could use this if register jump. So I could say here, if register 1 is equal to, let's say we wanted to run 5 times, then I would jump to tab number 2, which is at the bottom down here, and that would make it do that loop 5 times, and then finish. So let's put that right there. So now if we run our program, it should do that little back and forth move 5 times. And the program is stopped. And if we look at our registers, there it's at 5. So that's an example of how you would use the register and register jump buttons. So going back to the servo button, this gives you the ability to control a servo, and it's not a high-end servo. I'm talking 180-degree 5-volt servo, similar to what you see here, one of these little 5-volt servos. And if you look in the manual, there's a section on wiring that up. And so if you were to, and that's, if you look here on your input outputs page where you have some quick keys to control outputs and servos. So what these are, I can quickly just tie output 45 from my gripper to a button and click it on and off, and I could also do the same thing with a servo on and off. And so if we look down here, you can see that I've got the Arduino program pre-configured so that you have access to analog input 0 through 7 on the Arduino Mega. So if I had connected my little 5-volt servo to channel 0, then I could come in here in my program under servo, and I could go servo number 0 to 90 degrees, for example, and put that in my program. And what that's going to do is it's going to drive the servo that's connected to analog input 0. It's going to drive it to 90 degrees, or I could do 180 degrees, or whatever value I need that servo to go to. So that gives you the ability to, from within the robot code, control a small servo, and that comes in kind of handy if you wanted to control a gate latch or some other type of part movement that you wanted the robot to work with. So lastly, that brings us to the stored position button. So the stored position, if we look here on our register tab, going back to stored positions, what we have here is 16 stored positions you can use. You've got stored positions 1 through 16. You typically won't use very many, but what this is this is a placeholder for a position, for the X, Y, Z, yaw, pitch, and roll of a position. And so that'll make a little bit more sense when we get back here in here to some of our offsets and our stored position moves, which was why I was saving the moves for last, because I wanted to get through some of this this material over here before getting to that. But so for example, stored positions, if I wanted stored position number 1, the first one on the list, and I wanted the element number 1, and if we go back and look at the registers, element number 1 is the X, element number 2 is the Y, 3 is the Z, and so on. So element 1 is the X. So if I wanted stored position 1, element 1, the X, to be some value, let's say 5 millimeters, I could put that into my program, and when I execute that line of code, and we go back to our registers, the X is now a value of 5. And where this will come in useful is for procedures like stacking blocks or incremented movements, that we can move a position that will be offset by whatever we put in here. So if I wanted it to move every time I continually run a position, I want it to be offset by 5 or be offset by some incrementing value. That's where these stored positions are going to come in handy, and that's going to make more sense in a few minutes. I realize that probably doesn't make a whole lot of sense, but this stored position button behaves much like the button above it, where we were able to increment registers. So for example, I could come in here and put a double plus in front of that 5, and now every time that line of code runs, the X value is going to be incremented by 5. And so let's actually let me change this to a 3, so we do the Z height instead of the X position, so it's more like a stacking example. So let me delete that from the line of code and put in this that right there. So when that gets run and we look back at our stored positions, the Z has now been incremented by 5. So I'm going to put the X back to 0. And so every time we run this, our Z value increments. So if I was stacking 10 millimeter blocks, I would throw this line of code into a loop, and every time I would run through that loop, my Z height would be incremented, and then I could use one of my offset commands, which we'll go into more detail in a few minutes. So that's what the stored position button does, is it allows you to manipulate the values in a stored position register right there. And then the final button, the Get Vision button, so that's part of the Vision tab, and I'll do a separate video on that. And actually at some point I'd like to, this was using other open source software that's a little bit difficult to use, so one of my future goals is to redo the Vision tab and do my own integrated vision using OpenCV. So that's a future goal for the project, as is interpreting G-code. And so I've got a lot of goals for this project and a lot of things that will be added, but I will come back to the vision in a future video. So now, having gone through that material, let's go back to the the types of moves. So I'm going to start out with some basic move types, just a joint move and a linear move. So a joint move is known as a move J, which will just use all of the 6 robot joints to move in a sweeping motion to get from point A to point B. It won't necessarily be a perfectly straight line. It's just all joints working together. That's what a joint move is. If I were to put in a move L, that's a linear move, and what that's going to do is it's going to extrapolate a straight line from point A to point B. So if I was to insert, if I was to press teach new position, you can see now in the line it says move L. So what it's going to do is calculate all the waypoints along that line to extrapolate a straight line. So when you run a move L, sometimes there's a little half-second pause before the move starts, and that pause is the robot calculating out all of the, or the computer calculating all the waypoints to make that move happen. So that's the difference between a joint move and a linear move. We will come back to an arc move and a circle move a little bit later. What I want to talk about is the offset move. So offset allows you to move offset from a position. So let me let's delete that line, and let's delete that one and that one. And so if I come right here and I change this to move offset J and put in teach new position, you can see that it teaches the new position right where the robot's at. So this is very similar to just teaching a joint move, because it teaches the current position right here. So I've got my X, Y, and Z of the current position, but you'll notice at the beginning it is going to be offset by whatever is in stored position 1. And you can see here the stored position. This is what allows me to control which stored position I want that to be applicable to. So if I wanted to use stored position 3, for example, I could put in stored position 3 right there, make sure that's offset J, and then I could come in here and teach new position, and you can see here now it says offset stored position 3. So let me delete that, so we don't need both of them. So let's just use this example of stored position 1. And then let's say that at the very beginning of our program, the same way we zeroed out our register 1, let's take stored position 1, element 3, and let's zero it. So that stored position 1, element 3 gets zeroed at the beginning of the program. And then down here at the same place where we're incrementing our counting register to count that we're going to do this 5 times, let's take stored position 3, and let's say that we want to increment it. Let's do plus plus, and let's say 20 millimeters. Let's say we're stacking a 20 millimeter high block or something of that nature, and we will put that right in here. So now what it's going to do is the code is going to zero out the stored position element 3, the Z height, to 0. It's going to zero out our counting register, and then this is the top of our loop where we jump into our loop, and then it's going to say that if it has happened 5 times, we're going to jump out. And let's, now that I think about it, let's remove these 2 examples as well. So there's tab number 2, that's the end. So that's where it's going to jump out if we've done it 5 times. It's going to move to this position, it's going to increment the count, and it's going to increment the stored position register that we're offsetting by 20 millimeters. So what this is going to do is every time this executes, it is going to get offset by whatever is in that stored position. So let's go to the beginning and hit play and see what happens. Okay, so there it went through, and actually I put the counter in the wrong spot, so you saw it only went 4 times instead of 5 times, but you get the idea that each time it loops through this offset position is going to move according to whatever is in here, and you can see we're at 100 right here, so now it's 100 millimeters higher than where we started. Okay, so now let's talk about down here towards the bottom of the list, let's talk about move to stored position and teach stored position. So moving to a stored position, let's just delete, let's get all this out of here, kind of a blank slate. So let's say that I want to move to a stored position and I want to move to stored position 1. I would just click that button and the robot is going to move to whatever is in stored position 1. So that wouldn't really be too useful right now. Stored position 1 is all zeroed and you just get an error that the robot can't reach that position. But let's say that I wanted to first populate that stored position. I could go right above it and I could change this to teach a stored position. And when I click Teach Stored Position, it's going to pop in all my current values for where the robot's at. So you can see my X is currently at 352.84, and it puts that right here. So what this is going to do is each line of code here is going to populate the stored position and then move to that stored position. So you could populate a stored position and then execute to it. So let's just step forward through each of those. And if we look at our registers tab, these are all now populated with all the values of where we're currently at. And then if I execute it, of course we're already there. But I could use this and using the offset command, or there's other ways you might want to use this if you have an object that you're trying to move around, or you know the values of what you want to move. But I could come in here, for example, and change this from 352 to maybe I want to change that to 362. And then here, when I execute that stored position, now it's going to move forward by 10 millimeters. So this gives you the ability to populate a stored position, execute to a stored position, and then the other command is offset stored position. So this works exactly the same way as the example we just went through a minute ago with offset move J, but instead of offsetting from move J, you can offset from a stored position. So I could put this in here and do an offset of stored position, or I could even, for example, let's see here, if I did stored position 1 and I moved offset of a stored position, let's do offset stored position and teach new position, then you can see here in the program line we have offset stored position 1 offset by whatever's in stored position 2. So in that scenario, I could move to stored position 1, but offset by whatever's in stored position 2. So this comes in handy for block stacking and other, those types of activities. So if I was to put in, let's say 20 in stored position 2, when I execute this line of code, I'm going to move to stored position 1 offset of whatever's in 2. So that gives me the ability to potentially stack in rows, because then I could, in my program, I could set something up that offsets stored position 1 after 5 rows or after 5 pieces, and then after that's done, then I could offset by stored position 2 to do the next layer, for example. So I could use it for doing rows and layers. So that's where that would come in useful, is having a stored position offset by another stored position. So if I execute that now, you can see it's going to come up by 20. So that gives me the ability to offset in multiple directions. So now let's talk about the final two move types, an arc move and a circle move. I've got a bowl here just to kind of help illustrate. You can see the robot doing an arc or a circle with that as kind of a backdrop. So let's delete all of these. Get a blank slate again. So when we teach an arc move, we're going to basically have to teach 3 points. We're going to have to teach the beginning of the arc, the midpoint of the arc, and the end of the arc. So for example, if I wanted to teach an arc around the back side of this bowl, I would maybe teach the beginning here, the midpoint here, and the end right here to create that arc. So what I'm going to start with is a move A beginning, and so I will teach that position, and then I'm going to change it to the midpoint, and then we are going to jog the robot to the midpoint. Wrong way there. So let's say that that's roughly, let's go back. Let's say that's roughly the midpoint of the arc. I could teach that position. And you notice here that the beginning move of the arc contains the yaw, pitch, and roll, as well as the, if I arrow to the right here, you can see that it contains the speed, acceleration, deceleration values for the move. The midpoint and the endpoint are only the X, Y, and Z of the position that it uses mathematically for reference to create the arc. So now let's do the endpoint of the arc. So now let's say that the end of the arc is maybe right there. And so then we will teach new position there. So now when I execute this, it will move back to the beginning, calculate the arc, and make the arc move. And so there you can see it made the arc move happen there, and there is a little bit of a pause while it calculates the arc. So like I said before, with linear moves, arc moves, and circle moves, there's a short pause while it calculates that out. Okay, so now let's talk about the circle move. And the circle move is very similar. We have 3 points to teach. We have a center position, a start position, and then the plane of which we want the circle to be on. So let me try and explain that a little bit better. So using the bowl example here, the center point is going to be here in the center of the bowl. The starting point will be over here, and then the third point, the plane, could be anywhere on this plane. If you imagine like a flat sheet right here, the plane position could be anywhere on that plane in the direction that you want the arc to go, or the circle to go. So for example, if the circle, if you were on a plane like this, you could teach the center right here, you could teach the starting point here, and then teach your plane position down over here somewhere, and then it would do a circle in that plane, or at that tilt, so to speak. So the plane position gives you the ability to make that circle happen on different planes. So for this example, let's delete all of these. And then let's teach a circle center point and jog the robot to roughly the center of the bowl. Maybe come down a little bit. And so let's say that's the center position. So we'll teach that position. And then the start point. The robot will never actually execute this point. The robot will never come to the center point. That's just a reference position so that it can calculate the circle. And that's one thing I found really kind of annoying with programming ABB, FANUC, and KUKA robots, is that creating a circle, you got to patch together a bunch of move C's or arc moves to make a circle. So I wanted to find a way just to simply make a circle. So this center point will never get executed. The next point to teach is the start point, which is where the circle will start. So let's move back. So let's say that is the point where we want our circle to start. So I'm going to, let's teach the start point. And now I just need to teach another point on that plane, anywhere on the plane. So I'm just going to, let's go this way. Okay, so that right there should be fine. That's on the same plane. It's flat to the bowl. And it's in this direction, so the circle should go that direction. So we will teach that. So now we have our 3 points taught. So if I start up here, the robot will go to the start point, it will go to this point, and then it will make a circle. So let's hit play right there. So that's the completed circle there. So the last thing on this screen that I wanted to go over was the manual program entry field. This can be used for a few different things. This is great for editing or for adding comments. So I could add comments if it starts with, generally just start a comment with a couple of pound signs, and I could say that this is, say for example, start of circle move or something like that, and then put it right here, and I could insert that in, and I can put comments anywhere in the program you want, like that. The other thing you can use it for is for copy and paste. So for example, let's say I wanted the robot to move home, but I didn't want to call the home program. I just wanted that move. I could hit load program. I could come highlight that move J, and I could hit get selected, and it's going to grab that entire line of code, whatever it is. And then I could go back to our new program, and then I could insert that anywhere that I wanted, the robot to move home. I can insert that, I could litter the program with that move, or, anything I want to copy, I can come grab it and then insert it wherever I want. And then you can also use it for replace. So, if I wanted to replace that comment with this comment, I could hit replace, and it will replace that line of code. I could also, if I had if I taught a new move, let's say I taught a move J, taught new position, get that position, and I wanted to overwrite where I put the home position, I could hit replace that move. So you can use this for basically doing copy and paste type operations. The other thing you can use it for, you notice that all of the moves, I put a little asterisk and brackets here, and what that does is gives you the ability to name a position. So if I wanted this position that I'm on, where I just put that move, where I just taught that, let's say that that's my position above the bowl, and I wanted to call it bowl position. I could rename it down here in the entry field and then just hit replace, and it will replace that comment there. So each place you see an asterisk, that's a placeholder for you to be able to change that to a name. So you can give each position a name, so it's easier for you to know what each position is. You can name each one individually. The other thing that I didn't go over earlier was when we talked about when we were talking about offsetting from a stored position. So if I put in stored position 1 and offset stored position, and I hit teach position, it's going to automatically choose offset stored position by the next one. So it's a 2. So if I come in here and put in a 4, for example, and teach that again, it's going to be 4 offset by 5. It's automatically going to put the next one in, because I didn't want to litter the page with entry fields. So I basically made it like this, so that if you were to offset stored position 4 by 5, let's say you didn't want 5, let's say you wanted to be by 10, you could get that row, change that to a 10, and then replace it, and essentially change that to a 10. It also gives you the ability, if I wanted to change the speed, let's say I'm at 10%, and I really wanted that to be 20%, and I wanted my my acceleration to be 20, I could do that and change those values. So that gives you the ability to not only comment moves, change values in moves, change the speed, change the acceleration. So that's what the Get Selected tab allows you to do. So the final thing that I wanted to go over in this video is the Calibration tab. So at the top of this tab, we have the Auto Calibrate button, which we've gone over in the startup video on calibrating the robot. You could also, for setup and test purposes, you can calibrate the robot to the rest position. So if you were to, stand the robot up vertically or just get it basically in the right place, that gives you the ability to calibrate it to the vertical position for testing and setup purposes. Here we have a fine calibration positions. So what you can do is teach a reference position, and I recommend you do this. So if you have a workspace that you're working in, and you can run your gripper to some known position and mate it up with a block or some place in your work area where you can refer back to, you would jog the robot to that position and then click teach fine calibration position, and it will store that position right here in this field. And so this is your reference position. And then you could click go to find calibration position to go back to that position. But let's say that one of your limit switches got bent or damaged, and you tried to do an auto calibration and it just wasn't quite perfect. What you could do is click go to find calibration position and then see how far off it is. Like if you were, for example, you had taught a fine calibration position with the robot gripper flush up against a surface, up against a corner of a block or something, and you hit go to find calibration, and you could tell that it was off by a couple millimeters, you could then then jog the robot, you could go to your jogging screen and jog it by a couple millimeters to get it right back to where you knew the original fine calibration position was supposed to be. Then you could hit execute fine calibration position, this button right here, and that will put the robot right back to the day when you taught that position. We've also got, for calibration, you can calibrate individual joints. So for testing and setup, if you don't want to run the full auto calibration, you could do one joint at a time. And then the track is still just, at this point in time, I do not have a encoder on the track. It is the track is still open loop. So this would be the button you would press to calibrate your track when your track is all the way at the 0 position. And then down here, so if you are building your own custom robot, you could use these values down here to do a custom calibration on your robot. And what these are is these are the calibration directions. So if the limit switch, if you were to, for example, move the limit switch from one side of the axis to the other, so instead of needing axis 2, for example, if you didn't need axis 2 to go backwards to contact the limit switch, and you actually needed axis 2 to go forward to contact your limit switch, if you mounted your limit switch on the front side of the joint, you could come in here and change that value to a 1, and that would reverse the direction that the robot tries to calibrate the robot for the auto calibration. The motor direction outputs, that would be like if you had a motor that spun the opposite direction, or you mounted the motor on the opposite side. So instead of, in my example, when you're looking straight at the robot, the joint 2 motor's on the left side. Let's say that you mounted your motor on the right side, you could flip the direction that the motor is supposed to go for normal operation. So I could change axis 2, for example, so that the motor would inherently go the other direction. So that allows you to reverse motor directions if you were building a custom robot using the software for your own robot. These buttons down here are for testing. They allow you to disable encoder. So if you have an encoder that's got a grounding issue or is not behaving, you could just click that button. It will ignore that encoder, and you could run in a open loop mode for that encoder. So that comes in kind of handy for testing. Over here in this column, we have our robot calibration values. So these are already set up for the AR2, but if you were doing your own robot, you would figure out your angle limits, how far your robot can turn in each direction. So the AR2 and AR3 robots can move 170 degrees in both directions, and it takes the robot 1,500 or 15,110 steps to complete that move. So if you had your own custom robot, you would need to figure out from your drawings what your maximum rotation angles are, and then you would calculate how many steps it takes to make that move happen. And if you go to the main controls, you can jog in joints, or jog the joints in steps, so that you could, for example, if you wanted to go 500 steps, you could click that button and jog the robot in steps to help you determine how many steps it took to make a move happen for the calibration. So that's true for each axis. So, axis 2 goes from negative 129.6 to 0. Axis 3 goes from 1 to 143, and so on. And so you can see how many motor steps it took for each axis to do that. So that's what that is. The track is, like I said, the track is still open loop. So to calibrate your track, you would just put in the total distance. So the track that I had built previously could travel a total of 403 millimeters, and it took it 10,100 steps to do that. So that's where I put in those calibration values, and then I would run the track all the way to the left end and hit calibrate track at 0 to calibrate my track. And then finally, we have all of the Denevit-Hartenberg parameters. These are the mathematical numbers that represent the physical shape and orientation of the AR3 robot. So I have a whole series of videos, 8 videos long, that go over all of the forward and inverse kinematics and explain all of this. But if you had your own custom robot, you could come in here and you could, for example, change your link lengths. If your robot had a different length offset for the A1 offset, or a different different height, for your D4 parameter, you could come in here and change all your DH parameters for your own custom robot, and then you would hit save calibration on that. So I think that pretty much sums up everything that I wanted to cover in the programming video. So thank you for watching.